Sneak attack, Mr. Catlin here with 1.6, your practice problems for this week, and let's go. On the grid, we have a scaled copy of polygon Q using a scale factor of 2. Compare the perimeter and area of the new polygon to those of Q. So we got to make a scale copy of Q, and it has to be a factor of 2. So that means every side on this shape has to get doubled. So let's do that. So let's start, let's start right here. This will be, I want to make that corresponding corner. Now they went up 2, so scale factor of 2, I'm going to double that and go up 4. 1, 2, 3, 4. So that's going to put me there. And then we're going to go over, they went over 1, so we're going to go over 2. So over 2. And then they went up 1, so we're going to go up 2 to double that. Now, they went over 1, 2, 3, 4, 6. So we're going to have to go 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the longest side. Here we go. Let's see how straight of a line I can draw. Not too bad. Okay, and then from that point, they went down 2. So 1, 2, 3, 4, down 4. Okay, so this was 12, this was 4, these were both 2s, this was 1, 2, 3, 4. All right, and then they went over 1, 2, 3, 4. So I double that, that would be 8. 1, 2, 3, 4, 5, 6, 7, 8. That puts me right there. That's 8. And then they went down 1, so I go down 1, 2, and what do you know? It gets me back on line to finish this off. They were 3, so this should be 6. 1, 2, 3, 4, 5, 6. Yes. Okay. So we've got our new figure. They're calling this quadrilateral Q. This is quadrilateral Q. Q for quadrilateral. Why not? All right. And then it wants us to compare the perimeter and the area of the new polygon. So the perimeter of this one, let's draw it over here. It's a perimeter is add up all the sides. So 2 plus 1 is 3 plus 1 is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that one had a perimeter of 20. Now, this other figure that I made is going to be bigger. I'm going to guess 40, right? So let's see if that turns out to be 40. 4, 6, 8, and then plus 12 is 20, plus 4 is 24, plus 8 would give me 32, and then plus 2 more would be 34, 34 plus 6. Yeah, its perimeter is equal to 40. Well, that makes sense because it was scale factored up by 2, so the perimeter doubled, right? Now, here's where the weird part comes in. We're going to calculate the area of both of these figures, okay? So the area would be the number of squares inside. How many squares fit inside? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, logic would think that there would be 32 blocks inside of this figure. But watch what happens when we count the squares inside of this bad boy, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, let's do this faster. Let's break it up into big rectangle there, which is a 12 by 4. That's 48. What? We're already bigger than what we thought it was going to be. That's 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 1, 2, 3, 4. 64. Wait a minute. The area didn't double, but the perimeter did. So let's write about that. It says compare. So we could say perimeter doubled. But what happened to the area? The area actually got, watch this, 16 times 4 is 64. The area actually quadrupled. Area was multiplied by 4 to get the other one. It was 4 times larger. That's something that we've been discussing in class. And we're noticing that area doesn't scale the same as the sides do. And that's going to come back here in a little bit. Okay, so let's continue on. All right. Number 2, a right triangle has an area of 36 square units. A right triangle. All right. If you draw scaled copies of this triangle using the scale factors in the table, what will the areas of these scaled copies be? Explain or show your reasoning. All right, and what we learned in class on Thursday is that whenever you use a scale factor from one shape to a copy, the area doesn't multiply by that scale factor, okay? The area actually multiplies by that scale factor squared, okay? So that scale factor squared is what you multiply that by to get here. So if the scale factor is 1, and that gives you 36 square units, then whenever we go from 1 to 2, you would think, hey, it's going to get twice as big. But no, area takes that scale factor, which was 2, and they square it. And 2 squared would equal 4. So they're actually, like we saw in the previous problem, it's going to get 4 times bigger. 4 times bigger. Okay, so we got to do 36 times 4 to get that answer. So 36 times 4, 20. 12 plus 2 gives us 144. This would be 144 square units. Okay, now whenever they take that original and we go from a scale factor of 1 to 3, you would think, oh, the area is going to get 3 times bigger. But no, it's going to get that scale factor bigger squared. And what is 3 squared? That's going to be 3 times 3, which is 9. They're actually going to get 9 times bigger. So you got to do 36 times 9 for that particular one. 27 plus 5 gives us 32. So that one's actually 324. So if this pattern continues, think about what you're going to multiply by the 36 to get down here, because the scale factor got multiplied by 5, right? It's 5 times bigger than what it was. So you got to take 5 and square it, which means you're multiplying by 25. And honestly, guys, I'm okay if you get on here and search for your calculator at the bottom of your Chromebook. You can use a calculator for some of these larger calculations like this. You don't have to do all of that over to the side. Okay, you can use a calculator app or a calculator on your phone or something like that if you need to. But to show your work what you're multiplying there, so I can see that you're doing, 36 multiplied by 25. And for some reason, my calculator is not wanting to pull up at all. I guess I'll just work it out on paper. 30, 15 and 3 is 8. 12 and 1, 6, 7. And then we add. And that worked out nice. 900. That's a lot of square units. Okay. Now, as we get into these fractional ones, it's probably going to be easier to do on paper. So let's do a couple of these fraction ones. All right. So the scale factor goes from 1 to 1/2. That means that they're multiplying by 1/2 to get there. Half of 1 is half. All right. So same idea here. To go from the area of the shape, you got to multiply by 1/2 squared. Now, a number squared is the number multiplied by itself. So 1/2 times 1/2 is actually 1/4. So we're going to be doing 36 times 1/4 to find out what this answer is. And so we're essentially just doing 36 divided by 4, which is 9. That was actually going to shrink because the scale factor got smaller. It makes sense that there's less area inside. Okay, and then the last one, very last one. Okay, we're almost there. All right, scale factor is going from 1 to 2/3. Okay, so that's a times 2/3 times 1 to get there. So we have to get from 36, we got to multiply by 2/3 squared. Okay, 2/3 squared is actually 4/9. Okay, so we have to do the 36, the original area, multiplied by 4/9. Luckily, the 36 and 9 are common factors, so we can reduce, and we end up with 16/1. So 16. And that makes sense because 2/3 is more than a half. It's slightly bigger than what the half scale factor would be. All right, so there's that table filled out. That's a tough little table to fill out if you don't know that the scale factor has to be squared to get the area size. And that's something that we're going to talk in depth a lot tomorrow. So tomorrow I say will be Thursday if you're watching this video a different day. So we should talk about this more on class Thursday. All right, let's jump to the last part. Okay, last part, last page, last questions for this week's homework. All right, 1.6, the back page, and let's take a gander. We've got Diego has drawn a scaled version of polygon P, and he has labeled it Q. Now, if the area, and let me see if this is one that had I think it was supposed to have a grid on it. We'll see. If the area of P is 72 square units, what scale factor did Diego use to go from P to Q? Explain your reasoning. Okay, so he has this right here, and I guess I'm going to have to tell you how much space is inside of that shape, because otherwise, I don't think you would be able to answer that question. So let's skip that one, and I'll come back to that on either a later video, or I'll correct that another way. All right, so we've got an unlabeled polygon, and along with its scaled copies here, A, B, C, and D. All right, and for each copy, we have to determine the scale factor. So we got to do a little bit of counting. All right, so let's start with the original. The original 2. This one is a 1. This one right here is 4 tall. This one here is 3 tall. And this one here is 2. Okay, so let's say for each one. So for A, what was the scale copy to go from something that's originally 2 to a 1? Well, I got half the size, so that would be 1/2, right? And then B, it went from 2 to 4, so it doubled in size, so it had a scale factor of 2. Now, the toughest one on here is probably C. All right, so let's talk about C over here. We started with 2, we got to multiply by something, and we got to get to 3. We talked about how to get this answer, okay? Your answer is there in these two numbers. It's a ratio, 3 to 2. So it would just be a scale factor of 3/2, because 3/2 multiplied by 2 equals 3. Pretty simple. And then the ones that are identical, you should know what that scale factor is, okay? You know what that number is, I hope. Excuse me. And lastly, solve mentally, all right? So 1/7 times something equals 1. So you're thinking of it like this. Multiply by something, and I get 1. So like we just talked about, you got to do 1 divided by 1/7. You could think of it like this, 1 over 1 divided by 1/7, right? And keep, change, flip. Keep, change, flip if you did that in elementary. Or cross products, 7 over 1, which is essentially, if you take 7 and you break it up into sevenths, you get 1. So X for A is 7. And then for this one, you have something times an 11th equals 1. All right. It's still the same idea. You know, what number can I break down into 11ths and get 1? That would just be 11. Okay. And then, excuse me, 1 divided by 1/5 equals X. So this one actually tells you what to do. You're doing 1 divided by 1/5. So how many times will 1/5 go into a hole? Okay, that's kind of a mental thing. But if you need to do a keep, change, flip to see that it's going to be 5 over 1, you can do that because that's the third one. Okay, so for right now, I'm not sure. I'm looking at the copy of it here, and it looks like the grid did not make a very good copy, but I'm going to go ahead and tell you that I believe it was supposed to be, let's see, 1, 2, 3, 4, I think it was 6. The area of this was 6. Q equaled 6 units squared. Okay. I'm looking at it. I think I can barely make it out. It was supposed to be 6. So if they scaled it to a larger version and it went to 72 units squared, then you have to ask yourself, well, what did they multiply 6 by to get 72, right? Like what times 6? Well, I know 6 times 10 is 72. Excuse me. But what times 6 would give me 70? Or is 6 times 10 is 60, but 6 times 12 is what gives me 72, right? So 6 times. So we know that the factor there is times 12, but something multiplied by itself that gives us 12. And you know what? It might not have been 6. Maybe that was wrong. Draw a scaled version of P and labeled it Q. You know what? I'm just going to say right now for number 3, don't worry about that one because that grid, you can't really get it might not have been 6. It looked like it might have been, but you can't see it. So just scratch number 3. Don't worry about it. I'm going to take that one out and I'll announce that in class on Thursday. You won't have to worry about it. Me and these grids not making copies. What are you going to do? That should be all the help that you need for your homework. You guys have a good night.